Hi, everybody. Here is question 61 from chapter 7. This is a photoelectric effect question that's asking for the velocity of electrons emitted from a metal once light of a certain strength is shown on it. So first we have to solve for the amount of energy that the electrons are actually going to contain as they're leaving. We get that with the difference of the incident light and the work function, or the binding energy if you prefer. And after that, we can use the formula for kinetic energy to solve for the velocity of the ensuing electrons. Okay, so we did know that the work function of aluminum was equal to 412. It was 412 kilojoules per mole. Okay, so that means that our energy that actually arrives is going to be equal to the difference between the energy that the photons are containing and the binding energy of aluminum here. So it said that we had light that was corresponding to 471 kilojoules per mole, and we're going to subtract from that the 412 that's in aluminum, and that'll give us a total of 59 kilojoules per mole. And we're going to be calculating this in terms of atoms pretty soon. So let's just put this in joules per mole. Okay, so again, we want the amount of energy per particle, so we need to convert this out of moles as well. So that means that we have to divide that total by Avogadro's number. So this is joules per mole. We can do it like this: 1 mole per 6.022 times 10 to the 23. Cancel your moles. All right, and this gives us a value of 9.797 times 10 to the negative 20 joules, and this is per electron that's emitted at this point, right? So that's our energy value. So let's put that up here and erase the board, give ourselves some room for the rest of it. All right, so formula for kinetic energy is the mass times the square of the velocity divided by 2. Okay, so where are we here? So let's put the formula up. We'll stick some values in there. So mass times the square of the velocity over 2. We have 9.797 times 10 to the 20. Or actually, you know what? Let's do it differently. Because the numbers are so big, this is a lot easier to solve this thing algebraically. Use the letters to your advantage, and then plug your numbers in at the end once you've solved for everything. So velocity, in this case, we're going to multiply the kinetic energy by 2, divide it by mass. That isolates this, and then take the square root of the whole thing. So 2 times the kinetic energy divided by mass, square root. That gives us velocity. All right, I feel much better already. So that's going to be 2 times the kinetic energy that we solved for here, which is 9.797 times 10 to the negative 20 joules, divided by the mass. This is an electron, so this is 9.11 times 10 to the negative 31 kilograms. Right, and we are taking the square root of that, and we need to get units for velocity out of this, which should be meters per second. So let's do some dimensional analysis over here to confirm that this is going to work out. So 1 joule is equal to a Newton meter, right, and that is equal to kilogram meters cubed per squared, per second squared. right? So that joule over top of the kilogram. So we see this is over top of a kilogram in the question. So kilogram is going to cancel kilogram, and then the square root of meters squared over seconds squared is going to give us meters over second, which is perfect for velocity. That's what we want. Okay, so once we solve this thing, we come out of it with a value of, well, I came out of it with a value. You should come out with a value of 10 to the 5 meters per second. And there you go. There's your photoelectric effect work function question.